Hey gang, any guesses as to what I'm going to do with all this junk? Well, stay tuned and we'll see. You may have seen a video that I posted a while back that had this little gas engine here. Now this was a gas edger that was damaged, and I picked it up at Lowe's. The thing runs, I showed it in the previous video. I picked it up for $15, and I decided I'm going to try to make like a motorized something out of it. Well, I stumbled across what's left over from a three-wheeled trike. I don't know why they dismantled it, but the nice part is it gives me a drive. So now I have a straight axle that I can incorporate. As you can see, it's pretty greasy. So I have the axle assembly and some mount point, and I have what's left of the bike frame, and of course all this interacts with the back section here, so that all ties together. And I picked up this little bike, and this was at this scrap metal place. Paid $3 for it. Looks like it says Razor on the front. Not that that means much, but really all I wanted was the front section. I don't need the back half, but I needed a wheel and a set of forks. I didn't plan on using the one that came with this assembly because it's just not what I need, and that'll suffice. So what am I going to build? Well, if I have a straight axle, I'm going to build a trike or a tricycle, and I need to start cutting up some things and try to configure what I want to build. So obviously I have to use the back half for the back section, the axle, and maybe part of the assembly there. But I want it to look like a trike or tricycle. So if you look at this, this doesn't work for me because the curve is wrong, and I don't need a pedal mounting point. I really want the curve. And if you can envision it, I was going to turn this over and use that curve as a down, much like you'd see on a tricycle. So obviously I'm going to cut up some stuff and try to make that fit. And I think to start with, I'm going to dismantle this edger and get a look at the drive system. So that'll be the first thing I do. Let's tear that apart and see what's in there. Alright, so from what I can see, the only mount point for the engine is up here. It goes into this bracket assembly. The rest of it is just floating above these wheels. I'll show you that when I get it apart. But to get this apart, the first thing I'm going to have to do is remove this cover, and to remove that cover I'm going to have to remove the cutting blade. So this is a metric, looks like 8mm. Allen wrench will fit in the center there, and in this case I'm using a 15/16 wrench, and I have to determine whether that's got a clockwise or counterclockwise. Being that it rotates this way, it should be, let's find out. Let me just try to put some torque on it. Tell you what I'm going to do though. I'm going to add some leverage. That's it. So standard threads. Get that off. Hey, look at that. Perfectly good blade. Don't need it. Okay, so now I've got some more Allen head bolts in here, and I'm sure they're metric. Oh, I take that back. Those aren't Allen heads. Those look like Torx. Yep, those are Torx. So I have this little Torx set. I don't know what size this one is. Probably says it on it. That's a T40, in case you want to know. So I need to remove these bolts, and I'm sure that'll allow me to remove that cover. may have to adapt to a different drive system so I can use my cordless. Let's try this. Oh, so that's a carrier sleeve for a couple of bearings. That could be handy. That's really all it is. A couple bearings stacked on top of each other. Nice. Okay. Now, I need to see what's inside of this cover. See if I have. Those are definitely a combination that has either like an Allen head with a screwdriver. We'll go with the screwdriver. Aha! So it has a serpentine belt drive system with a tensioner on it. Look at that. That's pretty cool. Now, how does that come apart? Well, we're going to find out. I've got 3 more of these screws in here, and those appear to hold. They may actually hold the engine to this plate, but I want to get this cover off. And these have screws. Look like there's 3 bolts coming through from the other side. Yep. Get all this out of the way. This is bent, but there's 3. Those are probably 10 millimeter, but I'll find out. 10 millimeter. Now these other 2 are going to be a little harder to get to. I don't know if I can take, that's not a 10. I take that back. Surprisingly, these are 3/8, not a 10 millimeter. The 10 just happened to work on that first one. That's a nice little plate. Now let's see. So it appears that again this drive mechanism is just a pulley with a serpentine series of grooves in it. I don't know if I can use that for the drive mechanism on the tricycle, but I'll have a look at it. Nice little belt. MTD. It's got MTD on it, so that's probably who makes this thing, even though it says Craftsman on it. So, got to get this off and this other bolt out of here, and then this cover should come off. I don't know that I need to. I might be able to just pull the screws or bolts out of the engine housing and have it come right off. So let's see. That'll separate. Pull the cables, or the throttle cable and the kill switch, out, which are attached to the handle. And now I can decide if I'm going to use any of this stuff on the actual tricycle. But for now, that's not needed. So I'll have to look at this and see whether I want to keep it as is, or if I can adapt to like a chain drive. So I'll have to look into that a little bit more, but that was easy enough. Now, just to keep it simple, I'm going to remove the fork from the neck, I guess you'd call it. I'm sure there's a more technical term. Because I'm not going to need any of this, so just take off the big nut. Exposes the bearing. Then there's the other bearing. But again, I'm not going to need probably any of that stuff. Okay, maybe this will give you some idea of what I'm envisioning. If I use what would be the lower portion of the curved main frame and attach it to the neck of the 20-inch bike, that gives me the downflow like you'd have on a tricycle. Then I will probably salvage some of this back here and attach it to this piece so that I can attach that piece to it as well. And hopefully I can find enough space to fit the engine in there and make it look cool. But at this point I need to cut this up and see if it's going to work. I'm not sure if it will, but I'm going to play with it a little bit. So I've taken off the front brake caliper and disconnected the rear, and basically going to do the same thing I did to the other piece. Could be a unicycle. No. Okay, so maybe now you can kind of see what I'm doing. I hope I can see what I'm doing. As you can see, I have that. Nothing's welded together yet, obviously. It's just sitting here, overlapping pieces. And the seat post is going to get cut off, I believe. And I will merge these pieces together, and then the little engine will be up above, you know, where the drive sprocket is, and then I'll come up with a way to mount a seat somewhere up here, and I think it's going to work out just fine. I'm really kind of surprised it's looking as good as it does. So up here on the front post, the head, whatever you want to call this piece where the original frame mounted, I cut that off and ground off most of the welds. And then this piece, I started to V-notch it a little bit, and I'm going to hammer it together so it sandwiches tighter around this and weld that together. And as you can see, I've got it mocked in place. I'm trying to make sure that everything is together and in line. So I'm using a bubble level and verifying, you know, my angles here, and obviously front to rear, and I will tack it in place and verify those measurements. The wheels are just sitting on there, and I'm going to have to do something with these wheels because those wheels have bearings in the center, and I can't use that. And not only that, but they're too tight on the axle shaft. It won't slide on. That's why there's a gap in here and over here. Now this is actually a tooth drive that is designed to enter, has 3 prongs on it, and they're meant to interlock into something so that it will drive. But I have to come up with something, so I may have to make my own hubs that'll slide on to the shaft and then have a plate on it that'll interlock, but I'll come up with that later. For now, I just want to get the basics tacked into place. I'd say that's gonna not go anywhere. Of course, I will weld the bottom, but yeah. Well, let me show you a couple other things that have happened. I've been mocking up the back section here, trying to get it to align with that forward neck, and that's going to work out fine. I think what I'll end up doing is cutting a notch in the side of these tubes so that I can bring them in easier. I don't want to put a load on this setup back here where it bolts together, because if I need to take it apart, it's going to want to spring. So if I make it so that it relaxes and comes together, that'll be fine. I'll just have to reshape the end of these tubes a little bit so that they blend into the down neck. The other thing I want to show you is I was debating on how I was going to handle these wheels, because I needed to have something that would fit over this axle shaft on the right side, which has this plate, which is the drive mechanism. It has these 3 little pins sticking out, and that's actually what drives this wheel. This wheel needs to be a free wheel, because if you want to turn it, this isn't a drift trike, this is like a tricycle. So if you want to turn it, one wheel has to slip, otherwise it'll want to bind, and kind of like a 3-wheeler, if you ever rode one of those, it'll want to kind of kick you to the side a little bit. So here's what I did. I bought these wheels at Harbor Freight. These same wheels sell at Tractor Supply on sale for $11.99. I think they're normally like $14. Exact same wheels. They came with bearings in them, so they do turn, and they unbolt, which is great because that's what I needed. So the problem was the inside diameter of this bearing race is 0.645. The shaft is 0.665. Well, that's not going to fit. There's no way you're going to force that on there, and so I'm kind of stuck. That's why I had it mocked up the way I did. So what I did is I took this other wheel, the second wheel, and I disassembled it, and I drove the bearings out so that I could access or be able to handle the rotating surface. And basically I took this little bearing and I clamped it in a vise and took a rotary file, which I've talked about before. I've used, I've shown these in other videos. This is a rotary file, and it goes in the end of an air grinder. And what I did, I actually had a smaller one, smaller diameter, but I just took it on the inside and rode the radius of the bearing surface, or the mating surface, slowly. Now, this wheel, even though it's going to go on this side, I'm just going to show you, fits just like it should. Oops. There. So now I have a free wheel for that side. So I can slip that on. And again, you see these blocks of wood. I just have this to mimic the height. So that wheel slips on fine. But for this side, I need to fabricate my own hub, basically. So I have a machinist friend who turned me out 2 sleeves. And I only needed 1, but I got 2 just in case. So this will slide over the end of this side of the shaft. And what I'll do, and I'll show you this a little bit better, I'll make a plate with holes in it that'll slip into this drive plate. Just be a reverse copy, let's say a reverse image. And that'll be welded to the end of this sleeve. And then I'm going to take the bearings out of this wheel, take it apart obviously, and use this center hub, insert this inside, weld it all together, and that's going to give me the drive mechanism for this wheel. So there you can see the 3 pins sticking out, and this is directly connected to the axle. So I can turn this one, and on that side, if you can see it, it'll turn that bearing. It's not tight right now, so it will when I put the nut on that side. But basically, this will be the drive mechanism. And again, I'll make that plate, trim this to the length that I need, and then put it inside of this. And I'll show you all that. Now what I've done here is these 2 tubes, I cut them to match the shape of this down neck. And like I said, I cut 2 little slots right here so that the tubes can bend in easy. And then what I want to do is I'll bare the metal, do a little more fine tuning on this match so that it blends together. But I also want to make sure that I triangulate the axle to the front neck or head, whatever you want to call it. So by that what I mean is I'm going to do a cross measurement, because prior to welding this together I want to make sure it's square, and I'll show you what I'm talking about. Okay, so before I get anything ready or to the point of welding, I want to make sure that it's relatively square. So I've already got the forks square. I know they're fine. What I want to use is the upper bolt here where the handlebars mount, and I'll do a crisscross, basically a crisscross. I'll hook to the thread on the axle shaft, and I'll measure to the edge of the bolt at the top of the handlebars, and I'll get a number. In this case, let's just say 41.5. Then I will go to the other one and do the same thing, and this one's 41 5/8. So it's off just a 1/16 of an inch, really. Because if you adjust something, kind of show you where I was at. If you're measuring, and like I'm using the edge of this bolt right here, down, like I said, to each end of the axle. So if I'm off 1/8 of an inch, if it's 41 1/8 on one side and 41 on the other, the difference between the two is a 1/16. So you just move it a 1/16 of an inch and you compensate. Don't think of it as an eighth. It's only half, because one comes forward and the other one goes back, and that's where your difference is made up. So by making that square, then I can be more confident with welding things together. On the other side of that, I still have some room to adjust. That's why I like this setup, because although this was originally set up to tension the chain from a secondary drive, there was another unit here that carried the weight, or the load, from what was the crankshaft back to this unit, and then it went to the drive unit. The reason for that was this centerpiece was like a regular wheel on a bicycle, where you could crank forward and stop cranking and it would just free float. You can't do that with a straight axle. It would want to keep the cranks turning, so that's why it had this centerpiece. I'm not going to have that issue, so I'm not worried about that. I may even cut that off just to smooth it up a little bit. But these will slide. You can see there it's got a slot, and over there's a slot, which is on the same as on the inside here. So I can actually tweak this a little bit. If I want to twist it a little bit to compensate, I can do that as well. On these two lower pieces, I cut them off and reshaped them. It was easier to do that than try to bend anything, so now I'm going to weld them back together. I've got everything welded together, and that's about as solid as I'm going to be able to get it, I'm sure. So at this point, I've got the other wheel in place, but I still need to make a shim because there's a little bit of the axle sticking out, and I really need the shim to contact that bearing right there, or the bearing race, so that this thing will freewheel on that bearing. On this side, as I was talking about, these are the 3 prongs that are sticking out. I took a washer and I enlarged the center, basically with a step drill from Harbor Freight, one of those simple step drills. Enlarged the center hole, and it's very close to fitting this accurately. So that's a good thing. Now what I want to do is I'll cut notches where each of these pins are, so that this can slide on, and that'll engage this washer to this flange. And then, as I was saying, this piece will get welded to that piece. And then I'll move on to moving that inside of the wheel itself. So as I'm doing this, you can see I've got some marks on each one of the pins. And basically I'll just cut that out, make a U shape so that this will interact with those pins. Okay, I've got the piece made. Fits nice. And now I need to determine how much of a distance from this face to the edge right here where the bolt is going to hold it on to the axle. So I've got some dial calipers, and you can kind of try to measure this way and it'll work. That's one way you can use these. I would not try to do them this direction, but another way to do it is to use the end. And basically you would set this on the shoulder you're looking at and then move this against it, and it gives you your dimensions. In this case, I'm really just a few thousandths under 2.4. So I will cut this piece to fit the dimension that I need, and then get that in there and weld it onto this washer. Again, I'm using the 4.5 inch cutoff wheel from Harbor Freight on a Bosch angle grinder. I'm going to let that cool off. Okay, so what I've done now is I've clamped the washer in place. Want to make sure it wasn't going to shift on me. This is the piece that I trimmed down, and it's the right dimension now. So I'll slide that on, and you can see it just takes away that little bit of shoulder that was there, so that when I put the nut on, it's going to compress against that and hold this nice and tight. In fact, I like it that way better. Now, time to weld. I'll let that cool off. While that's cooling, I'm going to take apart this tire. And you always want to let the air out first, because the two halves are squeezing this tire together. And that's pretty simple. Just push in on the center of the Schrader valve. And the reason I have to take this all the way apart, for one, I'm going to be welding, but two, to get this bearing out of here, I have to take the half off of the wheel because it's behind this part of the wheel. Simple enough. And there, maybe you can see now this flange is bigger than the other half of the wheel. So in order to get these apart, it's pretty simple. All I'm going to do is take a screwdriver inside, and I'm going to catch the inside edge of that bearing, and with a mallet drive this out. So I'll try to show you that. So I'm just going to set this on top of my vise with the jaws open. Look underneath, make sure it's got clearance. Take the screwdriver, and the mallet. Switch sides. There's one. That's all there is to that. So with that welded together, I took my sanding disc and I smoothed the edges just a little bit because the wheel half was kind of hitting. So to be able to center it up, I needed to knock down some of that material. So that's what I did. Now I'm going to put this on top of this bare metal plate. That way it's grounded for the welding process. And then I'm going to clean up this edge as well prior to. But if I slip this on, the hardest part is going to be making sure this is centered. And I can tell you there's no easy way to do that. So basically I'm going to be eyeballing it and get it as close as I possibly can. I could take some measurements from like the inside edge of these holes to the center there. That I may do that, but otherwise you just have to trust your eyesight that that is square. What I've done is, after I've centered it, I started doing a series of welds around this edge. I could have put a washer around there, done a variety of different things, but this is pretty simple and effective. I think that's going to work just fine. Now, the other thing I'm going to do is weld the interior where the washer and that piece meet, and that's going to be really hard to try to film that. But basically I'm going to come in from the side and get some welds on that area. There it is. Flange welded, bolted back together. It's got air in it, and let's have a look. Oh yeah. That's nice. Of course, I can't guarantee how straight the wheels were to start with, because even the one on the other side that I didn't do anything to, it has a bit of a wobble to it. So that's the way it's going to be, but that's okay. Alright, so there it is. May not be the prettiest thing, but of course I'll clean it up, and when I get paint on it, it'll look a lot nicer, and I'll try to dress up some of the welds and stuff like that. But it does do what it's supposed to do. Got one wheel that turns for power and one that does a freewheel. So that's good. I think it's going to work out fine. And I think this will be the end of this video. Now, what I need to do in part 2 is figure out a way to get this engine mounted, and of course mount a seat and get everything in place and work the throttle up and all that sort of thing. So that'll be part 2. But for now I'm going to stop because there's some things I have to figure out with this clutch unit that is on the engine, and then I have to move the sprocket over, which it's going to move fine. It's keyed and it'll slide, so that's not an issue. But I'm pretty happy with it. Or as I like to say, I'm happy with that. So stay tuned for part 2, and if you would, throw a thumbs up on there, leave a comment, share, like, all those cool things. Help me grow this channel, and I'm going to keep on having fun building stuff.